Hey guys, welcome to Shari Azam. Today we are with Geography chapter of class 7th, Earth's movements and changing landforms. In this chapter we will learn about natural disasters like earthquakes, how they form, and what is Richter scale, what who are seismologists and what is seismologist graph. So let's start. But before this I would like to say that this video will be divided into parts, so please watch those parts also. I will be uploading that. So let's begin. Earth's movements and changing landforms. The big idea: movements of the earth, exogenic and endogenic forces, formation of major landforms, continents, ocean beds, mountains, plateaus and plains, earthquakes, seismology, volcanoes, active, dormant and extant, gradation, weathering, erosion and deposition, landforms, riverine, glacier, wind and marine. So these are some ideas that we are going to learn in this chapter. Now let's study who was Charles Francis. So, Charles Francis Richter was an American seismologist. He developed the Richter scale for measuring the magnitude of an earthquake. The Richter scale ranges from 0 to over 9. Severe earthquakes that measure 6 and above on the scale cause extensive loss and life property. So, the second community examiner who was Charles Francis Richter, and like who was he? Like he used to belong, like he was an American or a British, something like that. And what was his profession? Like he was a seismologist or a scientist or a doctor. So these types of question can come. So Charles Francis Richter was an American seismologist. He developed the Richter scale to measure the length, like to measure the magnitude of an Earth. So it used to in the Richter scale. It ranges from 0 to 9. So below 6, it was like not so. It do not cause extensive loss of life and property, but above 6 it was really dangerous. It the earthquake uh, can cause extensive loss of life and property. So let's here is an idea of the Earth's movements. It's a summary type, so we should read it. The intergenic forces are originate within the Earth crust, whereas the exogenic forces that originate outside the Earth crust. In endogenic, there are slow Earth movements, sudden Earth movements, and in exogenic, there are erosion and deposition. So, endogenic forces are types of forces that originates within the Earth, and exogenic are that occurs outside the Earth. So this is the major difference between them. You need to learn it. So let's start our chapter. Our planet Earth is dynamic in nature. Various processes that occur inside the and outside the Earth give rise to the different landforms that we see around us. So there are two types of forces: exogenic and endogenic and exogenic forces. I've told you earlier that endogenic are forces that originate within the earth crust. So endo means inside. And the second force is exogenic. Exo. Exo means uh, outside. So endogenic forces are forces that occurs within the earth crust, and exogenic forces are forces that occurs outside the Earth. So let's study about them in detail. The internal or intergenic forces that originate within the Earth crust create. So now these forces, intergenic forces, are further divided into two parts: slow Earth movements and sudden Earth movements. Slow Earth movements that form continents, ocean beds, mountains, plateaus, and plains. Whereas the sudden earth movements, such as volcanic eruptions, earthquakes, and landslides. So, from slow earth movements form various continents, oceans, mountains, plateaus, and plains. So, whenever we go to a hill station, so those mountains are made from slow earth movements. Always you need to remember that. That's an important question. And volcanic eruptions. From volcanic eruption are occur that eruptions are occurred by sudden earth movements, all earthquakes, all landslides, all sudden earth, all these volcanic eruptions are caused by sudden earth movements. The external or exogenic forces which originate outside the Earth crust cause changes on the surface of the Earth, for example, through erosion and deposition by natural agents such as wind, water, and so on. So, as I told you earlier, exogenic forces are forces that originate outside the Earth crust. Uh, and it changes the surface of the Earth. For example, here's some soil. So here is some soil, and above that there are rocks, small rocks, you can say. And when these winds come, these rocks used to just carried away by the wind. So they just from exogenic forces, the outside layer of earth used to erode. So this is the cause. This is the cause created by exogenic forces. And these happens when natural agents such as wind, water, and so on. In your exam it can come who names two natural agents. So the answer will be wind, water, wind, and water are examples of natural agents. Alright, let's move on. Formation of landforms by internal processes. According to the theory of plate tectonics, this theory is important, like the name of theory is important. Theory of plate tectonics, the Earth's lithosphere is divided into several large and small irregularly shaped plates called lithospheric or tectonic plates. So this this theory tells that the Earth lithosphere, we all know lithosphere is land, and this is made by the core and the outer mantle. And this lithosphere is divided into several large and small irregularly shaped plates. So these plates are different in sizes, and these small irregularly shaped plates are called lithospheric or tectonic plates. It is believed that these plates are floating on the molten mantle or ethnosphere, are in state of constant motion. These movements take place mainly due to the heat generated within the interior of the Earth. The movement of the lithospheric plates cause changes to the surface of the Earth. These plates are floating like they keep on moving and on the molten mantle. The another name of molten mantle is atmosphere. This can come in your exam name. The other word used for molten metal. So in that you have to write atmosphere. So these such movements used to take place due to the heat generated uh, within the interior of the earth. The In the earth there are some heat generated within the interior of the earth that causes the movements of these plates. And these movements of the lithospheric plates causes changes to the surface of the earth. As you can see in this picture, uh, here is mantle, and above that it is molten mantle or atmosphere, and above that there are oceans. There are lithosphere, then oceans, continents, and these words to know is also really very important. These questions can be formed like describe what is atmosphere or describe what is the theory of plate tectonics. So let's just complete this. So we from starting like from first we are learning that there are seven continents and five oceans, and we all do not know that how these continents formed, l- who from which theory these continents are believed that they are formed. So in this chapter we are going to learn this thing also mainly in this paragraph only, that is geography in depth. How were the seven continents formed? This paragraph is really very important, and there and around 1915, in 1915, one German professor, or we can say a German meteorologist, wrote a book, The Origin of Continents and Oceans, suggested the theory of continental drift. And and the name of that professor was Alfred Vinegar. He was a German meteorologist. In his book, he was a German meteorologist, and he wrote the book The Origin of Continents and Oceans Suggested. So in that book, that is The Origin of Continents and Oceans, he wrote about the theory of continental drift. And according to him, these all continents, like in modern day, we this is a modern picture that of continents and oceans, but they do not exist in real like earlier in 1915. Below earlier 19 Before 1915, these pictures were not real, as they were used to be like the all the continents were joined together, like and this picture was and this whole continent when they were joined together were known as Pangea. Here you can also see it is written, according to him, all the continents were once joined together as one supercontinent known as Pangea. This began to break about 200 million years ago, resulting in the drifting apart of the continents from each other. So they were all the continents were joined together. They were known as Pangea, and they were, here is not mentioned that how they broke down, but these were the movements caused by intergenic forces. We know in what is intergenic forces. Intergenic forces are the movements that occur within the crust of the earth. So these uh, uh, these all continents broke due to the movements caused in the earth's surface due to the due to the tectonic plates. So like they were broken down like this, and then after that this is a modern picture in which we used to see them. Earlier this it was like this picture, all the continents were merged together. You can see they are breaking down. So this is the history behind the continents, and this theory is really important. It can come in exam like which theory suggested that all the continents are joined together was known as Pangea. So you have to write theory of continental drift by Alfred Wegener, a German meteorologist. So let's see this one, where two lithospheric plates diverge or pull apart. It leads to rifts or formation of continents and ocean basins on the ocean floor by sea floor spreading. When two lithospheric plates collide or come together, it may result in the formation of monuments, trends, and volcanic or earthquake activity. So here it is written that when two lithospheric plates diverge or pull apart, it leads to, so when, like, for example, this is my one plate, my one lithospheric plate, or you can say the tectonic plates. So uh, when these plates used to pull each other, they used to pull. So this results in the formation of continents and ocean bases on the ocean floor by sea floor spreading. And when these lithospheric plates collide each other, like when they come together, so uh, this results in the formation of volcanic eruptions, earthquake activities. So you do remember that when when two lithospheric plates collide or come together, it may result in the formation of mountain strengths and volcanic or earthquake activity. And when they pull, and when the two lithospheric diverge or pull, then there is formation of continents and oceans. Now, formation of mountains, how the mountains were formed. The formation of mountain is attributed to the horizontal movement of lithospheric plates. The upfold parts or ridges are known as anticlines. The downfold or valleys are known as synclines. So this part, this uppermost part, is known as anticlines, and where the downfold or valleys are known as synclines. I hope you are able to see this brownish color layer. So this is known as synclines, and this uppermost layer, which is a gray or silver in color, so this is called anticlines. We used to see the mountain is like this, right? And if we don't know, and if we will just see the inside, there will be too many layers. So the first one, or you The uppermost layer is called anticlines, and the downfold is layer is known as, or you can say the second layer is known as synclines. I hope it is clear now. Now let's see the difference between old fold mountains and new fold mountains. Mountains ranges such as Appalachians in USA and Urals in Eurasia and the Aravallis in India were found millions of years ago due to horizontal plate movements, and they are known as old fold mountains. The old fold mountains have rounded peaks and gradual slopes with a lower height than the young fold mountains. So some mountains such as the Urals in Eurasia, the Appalachians in USA, and the Aravallis in India were found millions of years ago. So these are called old fold mountains. Now, if you do not know that in which AB or BCE they were formed, so we can get to know like the in modern days the mountains are like they are just pointed, whereas the old fold mountain used to be, they used to be like this. They used to be round in color, not round in color but round in shape. So those mountains were called old fold mountains, whereas the new fold mountains such as Himalayas, Rockies, Alps, and Andes on the other hand are young fold mountains, as these are still being subjected to horizontal plate movements that are pushing them higher even now. The young fold mountains are higher, exhibit pointed peaks and deep steep valleys. So the major difference between old fold and new fold mountain is that the old fold mountain used to be like it was for millions of years ago, and in new fold mountains they are like not so much time it has taken to be just made, but one major difference is that the in old fold mountains the peak of the mountain is rounded in shape, whereas a new fold mountain is like this, it is pointed, and whereas in old fold it is rounded. And one more major difference is the new fold mountains are much more higher than the old fold mountains. Folding. Now let us know about two different forms, folding and faulting. The wrinkling of the rock layers of the Earth's crust caused by the force of compression when two lithospheric plates collide is referred to as folding. So, the wrinkling of the rock layers of the Earth's crust when they wrink. So, the force that is caused by the compression when two lithospheric plates come together. So, this force is known as folding. When the two lithospheric or tectonic plates ring together, come when they collide with each other, when they come together then this force, then they cause a force, then that force is known as folding. Whereas the folding is when plates move, sometimes stresses causes fissures and fractions to appear on the earth's surface. This is no faulting. So the faulting is when the two plates moves, and it sometimes causes fractures to like it causes crack sometimes to the earth's surface. So that is known as faulting. I hope it is clear. And here's a word in this paragraph: geography intact. Meteorologists let us know what is a meteorologist. Meteorologist is a person who studies weather as a science, who used to study weather. Okay, so this is some types of faulting, like they have told very clearly the whole process behind faulting and folding. So You can read this, but we but still, if you have any doubt, you can write in the comment section below. I'm there to reply. So now let's don't waste the time and come to earthquakes. So what is an earthquake? An earthquake produces vibration or tremors on the surface of the earth. An earthquake is caused by either lithospheric plates colliding or rubbing against each other, volcanic eruptions, landslides, and faulting. Earthquake. We all know what is an earthquake. Like in many areas, still now some earthquake used to come, and why it is so. For example, here are my first tectonic plate, and here is my second one. I'm just remembering them first and second. So they are coming together, or they are coming together, rubbing each other, like just. Uh, you can take for example one matchbox and one matchstick. We used to rub that. Similarly, when these two plates rub each other, then these earthquakes erupt. This happens, and it this also causes the volcanic eruption and landslides. Now let us learn what is a seismology and who are seismologists. Now seismology is the study of earthquake waves, and scientists who study them are known as seismologists. I hope this point is clear to all of you, because this is such a simple point, that seismology is the study of earthquake waves, and seismologists are the persons who used to are the scientists who used to study them, who used to study seismology. So those persons are called seismologists. Now, we all know about Richter scale, but there are two more scales, that is seismometer or seismograph is an instrument used to detect and measure the vibration produced by earthquakes, whereas Richter scale ranges from 0 to over 9 severe earthquakes, which measure 6 and above on the Richter scale cause extreme destruction, leading to havoc and extensive loss of life and property. So, seismometer or seismograph is also an instrument that is used to measure the vibrations. It is used to measure the vibrations, and when we need to measure like the magnitude, like the earthquake was 6, 7, or below 6. So that's so when we use to measure the magnitude, so Richter scale is we use, and when we used to measure the vibration, then we use seismometer, seismograph. So let's move on. Now, what is an epicenter? The epicenter is a point on the Earth's surface vertically above the focus, which suffers maximum damage during the occurrence of an earthquake. Now, epicenter is the point, like for this is the focus. In this picture, you can see this is the focus, and above this, straight, this exact point is known as epicenter. Now, if for example, this is my focus, and there are too many layers, and here where there is like on the exact surface, after the layers, on the exact point where the focus is situated on above some layers, the uh, on the exact point where the earthquake is happening, so that uh, so that point is known as epicenter. Like in this picture, it is shown really clearly that this is the focus, and there are some layers and layers after that on the exact point on which focus is situated, below that epicenter in which focus is situated. If you will go above the focus on the exact point on that only, the epicenter is there. So this is called epicenter. Now what is focus? We have talked a lot about in epicenter that it is the point on the earth's surface vertically above the focus. Now what is in focus? Focus is is the origin or the place where the earthquake is under the surface of the earth. Like the focus of an earthquake is the point or place of origin under the surface of the earth. This is the earth. You can see this is the earth, and here is the focus. So here place of the place of origin, the place of earthquake is happening. And now how the now what if this mass seismic waves? From the focus, the earthquake's waves travels in all directions, and these vibrations are referred to as seismic waves. So when the focus happens, now it happens in all directions. We all know this, and so these waves, when these waves comes to us, so this waves is known as seismic waves. This picture is really very important. This can come in your first term or your any other competitive exams. This is really very important. Now here are some uh, earthquake. They are given like case studies. Nepal earthquake 2015. What happened in 2015? Like these much, around 9,000 deaths were there. 21,000 people were injured, and the focus of the earthquake was 15 kilometers under the ground. You can read this for the information. And this picture is also important. So now what is volcanoes? Where two lithospheric plates collide and one goes under the other, volcanic activity is caused. A volcanic is defined as a vent or an opening in the crust of the earth which allows hot magma, volcanic ash, steam, rock particles, and gases to escape from below the surface of the earth. The given figure on the right shows the different parts of a volcano. On the basis of their frequency, vol- the eruption volcanoes are classified into active, dormant, and extinct volcanoes. So, before reading that, what is this table? What is active volcanoes, dormant, extinct volcanoes, volcanoes? Let us first look at this picture. So, in this picture, they have told us about the different parts of volcanic eruptions, like how the different parts of volcanic. This picture is also really important. This can also come in your first term exam or any other exam. You need to learn this picture. This is really important. Now, uh, here you can see a volcanic eruption. So this is a magma that is coming out from the vent. Vent is an opening, as it is also, here it is written a volcano is defined as a vent or an opening in the crust of the earth which allows hot magma to come out. So the vent is an opening, it's the opening of the volcano from which the magma comes out. And not only vent, there are distinct type of so many parts of volcanoes. So many different parts are there for the opening of magma. For example, a side vent dike is also a part from which the magma comes out still. And this is crater, the middle one, and this is lava, as we all know, and these are particles of ash and gas. And the magma chamber, we all know what is a chamber. A chamber is a room that is full of a specific thing. So here, magma. This is the magma chamber, and now let us read some examples of like where volcanoes are present in. Many active volcanoes are present in a circular belt around the Pacific Ocean and the islands within it. This region has therefore earned the name the Pacific Ring of Fire. There is a belt around it is a imaginary belt around Pacific Ocean in which in so many islands in which so many island volcanoes are we can find volcanoes there, and that belt or that ring is known as Pacific Ring of Fire. The mid-continental belt, which runs along the middle of Europe and Asia and includes some very important volcanoes like Mount Etna, Sicily, Mount Vesuvius in Italy. So here also some, there is a middle continental belt in which in the middle of Europe and Asia, and in that volcanoes are also present like Mount Etna and Mount Vesuvius in Italy. So I hope this volcanic eruption picture and this geokinetic is clear to you now. What are types of volcanoes? From from fifth, or you can say from so many classes we are learning about the types of volcanoes. What are active volcanoes, dormant or sleeping volcanoes, or extinct volcanoes? So the active volcanoes are the type of volcanoes which used to erupt frequently, like they keep on going uh, erupt. They keep on going erupt. They have, for example, this is 2021, and one volcano has erupted in 2022. Suppose I'm just saying to suppose, and that is showing the signs of instability. Like it can also erupt in 2022, 2021, 2022. So these types of volcanoes that keep on erupting frequently are known as active volcanoes. Here you can see the examples: Mount Etna, Mount Vesuvius Island in India, and here is dormant or sleeping volcanoes that are they have been known to erupt in historical. So some mountains that have erupted in historical times, like they have erupted sometime, but they are not erupting from many years. They can they but there is a possibility of them to erupt in future. For example, Mount Fuji in Japan. Mount Fuji is a famous volcano of Japan, and Mount Mauna Kea in Hawaii, and Mount Rainier in USA. Now, what are extinct volcanoes? Extinct volcanoes are those types of volcanoes that even that do not that have not erupted in historical time, like they even have not erupted once. So those types of volcanoes are known as extinct volcanoes or dead volcanoes. For example, Mount Warning in Australia, Mount Elbrus in Russia, Mount Kilimanjaro in Africa. So here are some. So we have learned about volcanoes. Now let's learn about the formation of landforms by external forces. Process behind landform formation: weathering, erosion, deposition are processes responsible for the formation of different landforms on the surface of earth. Running water, moving ice veins, groundwater, and sea waves are the natural agents that aid in the process of landform formation. We have learned in exogenic that they erode the earth's crust, that they take away some small particles of stone. by the nature, and they are carried away by the natural agents such as wind, water, air. Wind and water. Now, here the weathering is the same as exogenic forces. So we can say like exogenic and weathering are same. But still, let's go through the weathering. Weathering is defined as the gradual process by which rocks break up and decay due to the atmospheric conditions in situ in place. That is, there is no transportation of rock fragments through the agents of weathering. It may be caused by chemical, physical, and biological processes. Weathering alters the landscape and is crucial to the formation of soil. So I hope this is clear to you because we have already covered it in the one force of Earth, that is exogenic force. Now here is a word called vent, that is what a volcano is defined as a vent. I have already told you what is a vent, the opening of the magma, but still we will just recall it. A vent is an opening for the escape of material upon eruption of a volcano. Now, what is erosion? What is deposition? Now, erosion, the process of wearing away from of the land surface and its transportation, running water, moving ice, wind, action of waves, etc. is known as erosion. So, the process of wearing away the land surface and by the natural agents such as running water, moving ice, wind, action of waves, and this process is called erosion. Now, what is deposition? The laying down or dropping of rock debris obtained by weathering and erosion in other parts of earth by natural forces. So deposition is a process by which the small particles of rock is carried away by natural agents in the other part of the earth is known as deposition, and from that place they may form the new type of rocks. So this process is called deposition. I hope till deposition it is clear. So in next video we will be learning about river, Rhine, landforms, and so on and so forth.